A little bit about myself first. I'm a self-employed joiner. I've been for about 23 years possibly, and born and brought up in Stornoway, but now living in Lawson and Grimshader. That's where the hydro scheme is. So decided to move over there and build a house. It's my mother's croft, and yeah, so that's where the scheme is, and I guess having a building background helped me build the scheme. Now let's see where we start. That's a little. I started with an overlay of the area. So I push this for the pointer. Right. And there we go. So that's the turbine house, and that's the house at the very end of the village in Grimshader. And this was a proposed route initially when I got my first consultation done, and the weir was up there just after the first loch. So that was way back in 2008. Started building my house. Just decided to take a walk down to the river. I had no word of building a hydro scheme, but I'd been watching Landward on a Sunday night, and it was showing farmers were diversifying into making their own generating their own power. So I went down to the river and I had a wee look, and I thought, yeah, I might have a chance here. So I phoned a company down in England, told them where I was, and they went, oh no, far too far away. But there was a new guy starting a business in around about Perthshire, Jamie Wallace. So I put me in touch with him, and Jamie came up and did a study for me. It all kind of snowballed from there, and before I knew it, I couldn't stop. it was going. The next one. So that's it's not much of a burn. You wouldn't think you would get much power from it. It's maybe 2, 3 feet, 4 feet at its maximum wide, coming down through the croft. It's got 25 metres of head between the turbine house and the dam, which I think gives you about 2.5 bar pressure, which is quite good. So yeah, I'm trying to think what we went after that. Back to that one again. The lock system. You can see the first lock. That's the main one. The water comes out of, but there's about 8 locks all feeding into that one wee river system. So it's about 2.5 square kilometres of catchment area. So there's quite a big area to catch the water. Yeah, the turbine we ended up putting in was a 9.5 kilowatt Turgo. Keep getting them mixed up. Turgo turbine, because it was the best for that head and that flow. I think the flow is about 80 litres a second through the pipe. So I don't profess to be any kind of expert on all the figures and numbers, but I'm just repeating what they found out in their study. So the next stage after getting in touch with Jamie was he did a desktop study, and just to deem if it was a suitable site. So it was. So he sent it off to get a hydrological survey, proper one done. So they do. They figure out what the flow duration curve is going to be to get it's Q95, they call the percentage of water you can use or extract from the river. So they got back to us and they said, yeah, it's worthwhile doing. So we cracked on. So then we went off into exploring where we were going to put inside the turbine house exactly. I had my own digger, so I just got cracking down there at the bottom, down by the river. I employed my newly retired father to help me with the scheme, so that was a good help. Yeah, there was an alternative scheme they had proposed as well, where they were saying we could divert all the lochs to another location further east of us. They were giving us 50 kilowatts, but I thought trying to get permission to reroute all the lochs into a different stream would be too much. I don't think I'd ever done it, to be honest. So then we started, once we, permissions, yeah, we got the permissions, quite a lot of permissions to get before you start. First of all, we had to get the landlord's permission, which was Sohal Estate, and they were really good. They quite happily gave us permission and didn't want anything for it, because the weir is actually on the common grazing, it's not on my croft. Then I had to get my neighbour's permission to dig through his croft, to get the common grazing's commission to allow that. And then I had to get a fish habitat survey done to ensure that there was no salmon or fish migrating up and down the river. So they got back and said they thought there was probably a small chance of small trout. They weren't worried. So I just had to put a fish pass in and leave a mitigation channel for keep water in the stream all the time. So I think it took close on 4 years to get all my permissions in place, and then I had the DSO as well to get my connection to the grid. So yeah, it was a bit of a plight. So eventually we got going. That's the wing walls for the weir. I made them in the workshop, just on the floor in the workshop in a big slab, and transported them over. I went down my neighbour's driveway. He hadn't built his house by then, I just scraped his driveway and dragged them out the moor. So by this point we diverted the stream round the side so we could do this work. So once we dropped that in, I just had to make the wee wing walls there, where you can see the shutterage up. So I was running back with a quad and trailer about half a mile from my own house with a patch of concrete at times. What's the number of slides? Well, no, there we go. That's just a pond line. I had to put it in the back of it to stop the water trickling around the side of the wing walls and undermining it. And that just gets buried underneath the back of it. So it was a punch hole mesh screen, about 1 millimetre diameter holes. I think you can get one called a Coandus screen, and it's got like a wedge wire thing which would have collected more water, but he was worried that it would also collect more debris, heather and grass and stuff would be harder to keep clean. So I go up there every month, 6 weeks, and give it a wee brush. That's all it takes, and it cleans it again. You can see it when the production goes down. That's the mitigation flow and the fish pass. So that's just a bypass. Yeah, the fish bypass for yeah, just keeping water in the river all the time. Even though if the hydro was stopped, this would still be running. So that's Jamie Wallace, the guy I contacted in Scotland. He just newly started his own company. This was actually his first hydro scheme, apart from one he built for his mother. And he's got a company called Highland Eco Ltd, and since done numerous schemes throughout Scotland. They've done really well. I think it was a rocket scientist degree. So he was really good. That's them just beside the burn. The burn was in full speed then, so that's probably the biggest it would ever get. That's the base of the turbine house there. So yeah, this was just going on to making the civils for getting the turbine house done. With the wee square you can see there, that's actually where the turbine sits on top. The water drops through it and then goes through a 500 mil pipe back to the river, so all the water's returned. It was very much done on a budget, this part of it, because I was building my own house at the same time. So we actually had to meet off with. I'm very thankful to my wife when I put the idea to her. I told her we'd have to kind of slow the house down and go off with half the mortgage to build this, and she was quite happy with it. So it put the fear in me. It's just I was just starting the turbine house with just any wood I had in the workshop. The Yeah, like I say, it was done on a budget. The door there, that came from, they were demolishing the Nicholson Institute at the time, so that's actually the door for the art block. Just made the turbines to fit that. So that's the house at the top of the hill. So it's about 100 metre of cable back up to the house. So it's 25 mil wire armoured cable and a Cat 5. I ran a Cat 5 as well because there's no phone signal or any reception down there, so it's been quite handy. I was quite lucky with the ground I had. It was quite, it was like a conglomerate. It wasn't too much rock. So I guess the biggest score I had was the pipe. I needed 500 metres pipe, sorry, to,
Sorry, a little louder.
sorry, I needed 500 metres of pipe to get the what, 300 mil pipe, and the costing was coming in about 13,000 for the pipe alone. And we were at a stage where it was a self-build mortgage. I couldn't take any more till I got to another stage, and quite tricky, and I didn't know how we were going to get any further on. I've been in the Stornoway lifeboat crew for 25 years, and we were out for a spin, and we were just out at Arnish at the killing factory there, and there's a big pipe going ashore from like the school shore, the fishing off the wellboats. And I just said to the boy beside me, I said, that's exactly how I need for my hydro scheme. And he actually worked in the fish farm, so yeah, and he said, oh, I know, we can get tons of that. And I said, aye, okay, yeah. But I didn't quite believe him. And then we got ashore and I said, so what's the crack? He says, oh yeah, they're getting shot of all these fish cages in gravel. And it's about the same size as that. So myself and my dad went over the next week, we phoned them up and said, can we come and have a look? And sure enough, that was them. 3 90-metre cages. I think they were no longer allowed to use them because there was no hard walkway all the way around them. There was just two pipes that the fishermen were walking around. So I think it obviously cost them a lot of money to get short of them, so they just agreed that for the price of them towing it up the coast and into Grimshader, I could have them. So I'm going to absolutely score up. Yeah, so I got them. We turned up one day, a couple of boats and 3 cages. I just tied them to the shore and off they went. We tried to pull them up with a wee digger and a dump bar. They wouldn't come, so there a few tides going on out, and then basically just got the chainsaw out this date, went down and cut it in half on the one end, swing out, and managed to drag it up like a snake. Then it was quite easy. But that's also when I found out that every single tube is completely full of polystyrene. So I didn't know that until I cut it. So if they ever got punctured, they would still float. So there was 540 metre length by 300 bits of polystyrene inside them. So I was still grateful for them. So we got them ashore. Tell my dad's face how excited he was to be stripping them. We had to strip them. We took the handrails off. It was mostly done by the machine once it punched out all the wee holes. And then I used the handrail as a plunger. I just sat over the pipe and stuck a handrail through with a plunger on it and pushed it through with a digger, and all the polystyrene popped out the other end. And that's them there actually. Yeah. So I was wondering what on earth we would be doing with all them, but they all went. Folk were using them for raised beds and all kinds of things. They would put them up on the raised beds so they wouldn't have to use so much soil and that. So they all disappeared all around the island. And even all the collars, they only went a couple of years ago. I think a guy down and back has made a fence with them. So nothing was wasted or dumped. So that's the pipe coming into the turbines. To join the pipes, I just had to buy these fusion collars. I think they're about £100 each, and but the pipes were 90 meters long, so I didn't need too many of them. In fact, we cut the pipes in half. I don't think we could drag the 90 meter. I think we did. So I just hired a generator and towed it along with the quad, and we got them all to work. And we buried the pipe. I left all of them open because I wasn't quite convinced I'd done it right. So just in case we sprang a leak. So it's about 500 meters from the turbine house up to the top. It's my dad for scale. So once I joined the pipe, I would just flick it in after I dug a wee bit more trench all the way up. I wasn't too hard on the old, but I would lift them in and out with the digger.
Yeah, you did that all. You watch your levels.
Yeah, we had to be quite careful with our levels. I got fright this morning. I went up the hill and it had been really heavy rain and the pipe was floating. I didn't realise because I backfilled it all the way up with water, nowhere to go. So I had to pump all that out before I carried on up. That was the deepest part coming up through the hill there. My own digger actually wouldn't do it. I had to borrow one of Pale's 13-ton digger. Very good of them. That's kind of, I guess, stand back. So they're not very clear. It's 12, 13 years ago now since we've done this. So you can see it. I think you can see the digger there. Is that it there? That gives you an idea of how far the pipe goes, 500 meters. So that's once the wing walls were in and the concrete was safe, you come off at 90 degrees from the weir. Once the water goes over the screen, drops into the dam and then comes along this low pressure pipe to a T-piece, which then takes it down the hill in the pipe and the thicker pipe. So the piece of pipe sticking up there, that's actually the very end of the pipe, and the head sensors in there, that's there's a cable from the head sensor all the way back to the controller, and that's actually what governs the turbine down at the bottom. It's a head level up at the top. That was just connecting the last of the pipe. I think I only had 2 or 3 days left before the feed-in tariff came along. So it was just at this point when the boy who designed the turbine, a company from Wales, Hydrover Turbine, and Jamie turned up to get it all installed, and I still hadn't got the pipe connected. So they just came off the ferry. I didn't even see them coming up the hill, and I just saw them jumping in the trench. They got straight in amongst it. They're really good guys. Yes, I forgot to say that at the beginning that the turbines are all, they're not just off the shelf. They have to be built to the head and the floor, and the capacity. So this guy in Wales, we sent all the information to him, and he built the turbine to suit. So that's Jamie Wallace, the guy who designed the scheme. That's the same day he's putting the head sensor in at the end pipe there. This old fellow here was Ronnie Grimm. He was helping out. He was retired, bricky, stayed in the village. Fortunately, passed away last year. He was a good hand. So that's the turbine getting installed. You can see the pipe coming in the back corner there, and it got bolted on via a massive butterfly valve to Richard's turbine. The controller comes from another company. I think I've got a bush light of that actually. That's better. The controller in the corner comes from another company called Sustainable Control Systems. Nigel Smith was his name. So he designed that system, and I think he wrote books on how to turn generators into motors. So it's actually just a generator, a motor running in reverse. That's generating electricity. So the controller there, and that controller there, so connects it all to the grid and makes it legal and passes all its disconnection tests and stuff like that. So that's the underside of the generator. That's the turbo wheel. So you can see it in a wee minute, but there's a spare valve comes in one corner, and then there's 3 butterfly valves open up as the flow continues up on the other ones. So that's, I think that was the first water that went through it, coming out the bottom there. And there's a wee window on the side, so that's a spare valve you can see there on the right. I think I have another picture of that somewhere. No, I thought I did. I think I must have sent it to you before I changed that. So that's a spare valve. So basically that's the valve that controls the whole system. That talks to the head sensor up at the top. So the controller has a head aim, so it's like a window that it's trying to reach, tries to bring the water down to it. So that opens incrementally, and it keeps an eye on the head aim. So as the head comes down, that'll keep opening up, and if it reaches its head aim, it'll stop. But if that opens completely and still above its head aim, it'll tell a butterfly valve to open on one of the other nozzles. So if that one opens all the way up and it still hasn't dropped below its head aim, it'll open another butterfly valve, and so on. And then as the head drops below head aim, it'll close the spare valve a wee bit to bring it back up. And it just keeps everything, keeps the pipe full, basically. So that's the control system. It's the main box, so that's the one that connects, does the whole connecting to the grid and everything. And there's 2 12-volt batteries in there that run the spare valve and the butterfly valves through the other box, and that's in case the power goes off, it still has to have the capacity to shut down. So that's what the 12-volt system's for. Otherwise, it would run away, and it makes that. I can't remember what spins that under road, but when the power trips and it comes out of the road, the generator really spins up, and you can actually hear it from the house. It's really noisy until it shuts down. It obviously doubles and triples the speed of spinning. So that's 3 stooges there. That's Richard Drover on the left. He designed and built the turbine. Jamie, he designed the scheme, and Buddy Grimm. That's a pressure. That's on the top of the pipe there. That's showing too bad at the minute. It must have been running. That's a power 9 kilowatts at the bottom. The dam in all its glory. This is the outlet from the turbine house, and it's just got a screen on it, so the waters can run up there and get stuck in the machinery. So you have to have that. The turbine house isn't very pretty, but that was done with leftover stuff from my workshop as well. Couple. Maybe I looked at my notes, I don't know if I've missed anything. Yeah, I guess that's pretty much it. It's pretty much maintenance free. I've had very little bother in the last 12 years. It has to. I've had a wee issue with the spare valve. There's a spider inside it that holds it central. That's just a wee frame. That just needed replacing a little bit stainless steel welding it. One of the butterfly valves went. That's basically it. It's been running fault free since I clean it maybe once. I meant to do it every year. I'm meant to, but I'd like to do it every year. Get a pig through the pipe from one end, a big 300mm foam swab. Just jam it in one end and open it up at the bottom.
You didn't know that, though?
No, I didn't know that.
No, unfortunately, I think it's a rope, the full length of the pipe, but would pull it through. You didn't need to, because the friction of the water pulled it through.
Yeah, I did about 1,000 metre rope up there. Pulled 500 metres through, tie it onto the swab.
I don't know how you You were going to get the rope through.
I thought, yeah. I was making it up as we went on. But anyway, Richard Drover came up to fix that spider, that's what it was. And he was going for the ferry in the afternoon, and I told him I hadn't cleaned the pipe yet. And he said, oh, we'll do it now. And I said, that's impossible. You're going for the ferry in 2 hours. He just ran up, took the head sensor out, jammed the phone thing in, ran down to the turbine and opened it up. And it just got sucked through the it's quite amazing the amount of peat that actually does stick to the inside of the pipe. So when it takes about 45, 50 minutes for the plug, the pipe to come through, so it's quite anxious before it does come through. But you can see it coming because the water just turned black. So it's a good sign that the pipe's getting that clean out. And that was it. Yeah, that's the very end. Pint of entertainment there, but to finish off. Yeah, so the poor family put up with a lot. For a year we're building that. I was never at home, and Isla was stuck with the kids, and I think she was doing her RTPI planning or something at the same time. So yeah, it was a family affair. I think that's it really. There's